Hey everyone. So, in continuation with us talking about the biological level of analysis in psychology, we're going to look today at this idea of neuroplasticity. And neuroplasticity, as I'll define in a couple minutes, is so important in terms of not only how we look at the brain overall and our knowledge of the brain, but also in terms of the great knowledge it gives us about the ability for humans to adapt, the ability for us as individuals and for others to grow and to change. So this first video clip here is from the series Brain Games from National Geographic. So what I want you guys to do, and you can pause it right here, but I want you guys to, on the copy of the PowerPoint that you would have, not this video. I want you guys to watch the video. It's going to take you through these glasses that make it so that you are seeing what is a couple inches to the left or right of where things actually are and how the brain sort of adapts to these particular parameters, this change in how you are seeing the world. So I'll pause for a couple seconds here for just to give you guys space to pause this video and go watch that. All right, so in terms of how neuroplasticity works, we're going to start off by just looking more directly at the systems in which our brain and the messages from the brain sort of go. So we've talked about before the idea of neurons, and messages from the brain travel throughout the body in pathways with billions upon billions of neurons. And each space between each neuron is this small gap called the synapse. And based on which connections that particular synapse is making, known as synaptic connections, as we see there, the brain can develop in very, very different ways. And this can be based on your experience, it can be based on particular injuries that occur. All of these things can sort of shape the direction that our brain develops in. And within each of the synapses, we've also talked about this before, there are chemicals called neurotransmitters. These carry the message across to the next neuron. And this can sort of change or mediate the effect in the communication of this particular message. So now that we've sort of talked about the background on this, here comes the definition of what neuroplasticity actually is. And so this is the brain's ability to reorganize itself in response to the environment and biological changes throughout the lifespan. So in essence, there are environmental causes for neuroplasticity, there are genetic causes, but we're going to really focus on the, in some ways the genetic causes and the environmental causes to some extent today. So what this allows us to do is to compensate for injury, diseases, adjust to the needs of our environment. It allows us to continue living even in the event of something traumatic occurring, whether that's to our cognitive abilities, to the structures of the brain, all of these different things. And there is sort of an assumption that underlies this theory, this principle. As behavior changes, there must be a corresponding change in the neural circuitry that produces behavior. Right? So how would we be able to do it if there's not a structural change also taking place? If the wiring is not there, you possibly could not do it. And so this is much akin to, let's say you had something that needed to be plugged into the wall through an electrical circuit. That thing is not working unless the wiring is created, the circuitry is completed to you actually plugging that in. You would have to pop in a battery. You would have to do something else for this thing to actually work. And so focusing back on the brain, neuroplasticity becomes a normal functioning of the nervous system. It can both help us, and in some ways, as we'll talk about today, it might even hurt us. So when talking about neuroplasticity, there's a few different principles um, we're going to talk about. These researchers, Kolb and Robinson, outlined 8 principles of neuroplasticity, but we're only going to focus on 3. So the first one, for our purposes, is neuroplastic changes are time dependent. There may be times where neuroplastic changes have occurred, but they might not necessarily be important or permanent. So for instance, if we go back to the brain games video, the fact that this person has adjusted to the glasses for 45 minutes or however long they wore it, that doesn't mean that for the rest of their lives they're going to be able to just completely adjust to this new perspective in terms of vision. Um, it's going to be more likely that within a couple days, if that person put those glasses back on, there would be a similar adjustment period that would still need to be taking place. And so our brain sort of reacts to what is going to be important for us and not important for us. The second principle here are that neuroplastic changes may only happen at certain ages in some contexts. And although we've often assumed that young brains become more malleable than older brains, the more that we've seen this and studied this may not necessarily be true. Although it's much harder for adults' brains to sort of change as completely as young persons do, um, there's still a case to be made that sometimes they are still able to be taught new tricks. It's sort of like the old saying, you can't teach a new old dog new tricks. However, the more that we studied it, we found that in some cases we can teach an old dog new tricks. The third principle here are that not all neuroplastic changes are good. So for instance, if you abuse drugs or alcohol, those are neuroplastic changes. That is changing the chemical wiring of your brain. And so it may change, for instance here, prefrontal neurons, which may lead to undesirable behavior in addicts. Your reward system being changed, your ability to effectively moderate your behavior under the influence of certain drugs may not only for the short term be changed, but for the long term as well. A lot of the neuroplastic changes that we see, especially in normal circumstances, are oftentimes tied to experience. So experience and the ways in which we live our life and the activities that we're involved in, the knowledge that we have gained, all of these sort of things can largely impact the route that neuroplasticity changes or takes. This can change our pre and postnatal experiences, so our experiences in the womb and outside of the womb, the stimulating environments that we encounter. If you are someone that is studying music, is studying languages, are involved in a lot of different challenging environments, this can really change how we grow and how we develop. Sex hormones, testosterone, estrogen, progesterone, all of these can be impacted by changes within the brain. Diet, genetics, drugs, brain injury, stress, all of these experiences can change how our brains are wired for the better and for worse. Stress in some forms can be shown to be good for the brain, but in most cases, it actually really, really changes for the long term the nature of how we live our lives and can even, in some cases, shorten it. So when we talk about research and neuroplasticity, most neuroplasticity research has been performed on animals. As we talked about in the slideshow on, um, you know, research in the biological level of analysis, uh, a lot of times biological studies have been performed on animals because it would be too harmful to humans for us to um, test these sort of conditions. And so, um, if we're trying to see a change in the brain wiring and how certain situations change brain wiring, for instance, we can't cut a human's brain open to see those brain changes. And like we talked about before, even in the case of animal studies, we need to make sure that this is for relevant um, scientific inquiries and that the study of animals is done correctly. Now, there is a chemical substance called BRDU, which has been shown to mark neurogenesis. So this is the creation of new neurons. This denotes, this shows neuroplasticity in the brain. However, it's very, very toxic for humans. And so oftentimes it has to be used on animals in order to see the changes and to see where this neural development is taking place. Now, in terms of humans, how they've sort of studied this thing, most of the time it's been studied on people like HM, for instance, who we've talked about several times, who have gone through injuries, illnesses, that sort of stuff. Even in a case like blindness, as an example, the brain adapting to a loss of sight by using the occipital visual cortex for non-visual processing. And so using sort of, for instance, hearing centers in order to see or to process um, sound and light um, may enable us to see that these neuroplastic changes are taking place. Most people who are not blind would not be using these parts of the brain to be able to hear. And so that oftentimes when you take away one of our senses, our brain makes an adjustment for that. So that's going to lead us into our first study. And we've seen this picture before, and it's because we talked about it with localization. However, the whistled language study from Carrerius et al. 2005 also has a strong connection to the idea um, and to the ideas, I should say, of neuroplasticity. So again, this is a quasi-experiment. They wanted to discover whether the whistled language was also processed in the left temporal and inferior frontal lobes, and to see if the brains of Silbo-Gomero users, or the whistled language users, differed from the brains of non-Silbo users. And so they took two scans, a baseline scan and active attention scan, where they had people listen passively and then actively to Silbo and Spanish. So the results, again, the brains of skilled Silbo whistlers in both tasks use parts of the left hemisphere associated with speech production. But when using both Spanish and Silbo, they were also using activation in the right hemisphere. And so this experiential thing, this part of experience where they're using this whistled language while also talking in Spanish, caused their brain to use parts of the brain differently than other people. And so this showed a neuroplastic change. And like I've talked about in the past, you're going to want to make sure that if you're ever given a essay question on neuroplasticity, that we are actually covering this um, only from the perspective of these neuroplastic changes. Although localization is in some ways connected to it, you're going to want to all the way focus on neuroplastic changes. Another important neuroplastic change that ends up occurring is in the use of drugs and alcohol. And so many will argue that narcotics and prescription drugs can change the wiring of our brain, not only in the short term, but in the long term as well. And this can take place not only in terms of like street drugs like marijuana or cocaine or methamphetamines, but also in terms of drugs that are used for anxiety, depression. That changes the chemical wiring of the brain. In that case, in most times, hopefully for the better. So one such example is Prozac. This causes neuroplastic changes that lessen the effect of depression on the brain and on the individual as well. So the next study we're going to look at is an idea of neuroplastic changes taking place within children, and this is also within speech perception. So this is a famous study called the Ba-Da experiment, and if you have the PowerPoint version of this open, not just this video, I would suggest looking at the video on the last slide because it really gives you a good visual of what the experiment entailed. So again, this is a quasi-experiment. Um, this demonstrated that children's speech perception reorganized by the end of the first year of life. And so what they did was that they used English and Hindi words. There were two phonemes used. So this is like sounds within the English language. So they used ba and da. Although adult Hindi speakers heard three categories: ba, da, and da, which was a Hindi phoneme. However, adult English speakers can't hear that difference because the Hindi da is not an English phoneme. So the aim of the experiment was to see what babies could hear and at what age developmental changes occurred. So they took two groups of infants. One group was aged between 6 and 8 months, and the other group was aged between 11 and 13 months, and they had them hear these sounds from this little doll. Okay, and it would just continue to repeat these sounds over and over again. And so the independent variable for this, the age and the language sounds, and the dependent variable was the age when a child could no longer hear the difference between the sounds. So again, they use this head turn method where they would have this doll continue to talk, and the head turning, if the baby turned towards the sound, that meant they could hear it. If the baby did not react, that meant that they could not hear it, or they could not tell the difference, or did not recognize it. So all babies were conditioned to turn their heads away from a researcher to a box with a toy animal, okay, which was clapping cymbals when a sound category changed. Uh, and there was a random pairings with the sounds to ba, da, and the Hindi da. So the results were, quite staggering. So those in the 6 to 8 month category heard all three sounds. They turned their heads to all three sounds, including the Hindi da. And these were all English-speaking children, or would become English-speaking children. However, English babies between the ages of 11 and 13 months did not turn their heads to the Hindi da, which meant that there was a neuroplastic change taking place. Our brain had effectively taken out our ability to recognize this Hindi da. Because what happens is that when we are born for the capability of universal language speaking. Our brain doesn't know what language it's going to need to speak, and so it holds on to all of them. But within the first year of life, we start to get a sense of what we're actually going to need and not. So just like you would delete files off a computer that you no longer need, or you would do some spring cleaning around the house to get rid of items of clothing that you no longer would fit into, our brains are making a similar choice. They are saying to ourselves that we do not need this and we're going to cut it. Now that does not mean that we could not learn the Hindi language later on. But what it does mean is that, for the short term, our brains, and, if we never learn Hindi, I guess, for the long term, have decided that we're going to clear some space for stuff that we actually do need in this moment. And a strength of this particular study is the idea of triangulation, and you see that in the bottom corner there. So they used many different sources, the application of several methods or study types to prove this or show that the study was correct. Another form that neuroplasticity takes is in the environment. And so the environments that we are surrounded by can also change the makeup and potential for our brains. Long periods of stress, those induced by a negative or pressure-packed home, school, work environment can also chart long-term changes to the brain. And one way that this could occur is within poverty. So this last study we're going to look at here is called the Great Smoky Mountain Study. And the aim of this was to investigate the effects of the changing poverty status of the family on social development of children. So they took 1,500 rural children aged 9 to 13. 25% of them were Native Americans, 75% were white. This was a longitudinal experiment studied over many months or years. And the children were given annual psychiatric assessments over 8 years. What happened here is that they had 3 different family groups. There were those who started out the study in a low socioeconomic status group. They used to be poor. There was a group where the children were poor throughout the study, and then there was a group where there were children who were never poor. So what happened in the study was that there was a casino that opened in town halfway through the study. And before the casino opened, the poor children had more psychiatric symptoms than the never poor group. However, after the casino opened, those students who went from the poor group into a middle class or higher class group suddenly dropped in terms of the psychiatric symptoms to those that were never poor. And so there was a neuroplastic change that took place because of the environment that they were in. At first, they encountered maybe greater bouts with hunger, maybe greater bouts of stress from home, maybe their parents were more worried about finances, and so that carried into the home environment. All of these things, affected the child. And so what ended up happening is that their externalizing behaviors, those that included aggression or conduct disorder, were less likely to be shown for those who had sort of climbed the social ladder, so to speak. However, internalizing behaviors like anxiety, depression were not affected. Even if you sort of became richer as a family or got into a new socioeconomic class, you were not sort of affected by internalizing behaviors. And then the levels of psychiatric symptoms among the persistently poor also remained high as well. So the conclusion here is that since family characteristics did not change during the course of the study, the observed reduction of externalizing symptoms and the effect on the brain may be attributed to changing financial status. And so family income might have an effect on these externalizing behaviors. And these things that may impact our environment may also impact our behaviors and may also impact our brains. And it's a worthy thing to think about, especially as we talk about the idea of neuroplasticity. All right, that's the end of my talk. If you have any questions on neuroplasticity, please get in touch with me. And I hope you continue thinking about the great change that can take place when we put ourselves in stimulating environments, when we challenge ourselves. All of this stuff can change the very wiring of our brain and can improve us. In most every case, there is no stopping us from improving ourselves, and it's never too late.